Hi there, science fans! Welcome back to Science in 10 Minutes with Jaden. Today, we're diving into a fascinating natural process that's essential for life on Earth, the water cycle. Get ready to learn how water constantly moves around our planet, changing states along the way. From soaring clouds to refreshing rain, the water cycle keeps things flowing. So grab your lab coats and thinking caps as we explore this amazing journey of water. The water cycle is like Earth's giant recycling system for water. It's a continuous process where water moves between the Earth's surface and the atmosphere. Think of it like this: water changes state from liquid to gas to liquid again, traveling in a big, continuous loop. This cycle ensures we always have water for drinking, growing crops, and supporting all living things. It's a pretty amazing system, and we're going to break it down step by step. Our first stop on this watery adventure is evaporation. Evaporation is when liquid water changes into a gas called water vapor. You know how the sun feels warm on your skin? Well, that heat energy from the sun is the key to evaporation. When water absorbs enough heat energy, its molecules get excited and start moving faster and faster. Eventually, they move so fast that they escape from the liquid surface and become water vapor in the air. It's like they're leaping off the surface and floating away. Evaporation happens all around us. Think about a puddle after a rainstorm. As the sun comes out, the puddle gets smaller and smaller until it eventually disappears. That's evaporation in action. The liquid water in the puddle is turning into water vapor and rising into the air. You can even see evaporation happening in your own kitchen. When you boil water in a tea kettle, the water level goes down. Where does the water go? It evaporates into steam, which is just water vapor that's hot enough to be visible. Section 5. Condensation from gas to liquid. Now that the water vapor is hanging out in the atmosphere, it's time for the next stage, condensation. Condensation is the opposite of evaporation. It's when water vapor in the air cools down and changes back into liquid water. As air rises higher in the atmosphere, it gets colder. When water vapor in the air cools down enough, it loses energy and slows down. The water molecules clump together, changing back into liquid water droplets. Section 6. Condensation in action. Dewdrops and eyeglasses. Condensation is responsible for those tiny dewdrops you see on grass and leaves in the morning. This natural phenomenon is a beautiful example of how water vapor in the air transforms into liquid water when it comes into contact with cooler surfaces. Overnight, the air near the ground cools down. As the temperature drops, the air can no longer hold as much water vapor, leading to the formation of dew. As the air cools, water vapor in the air condenses on the cool surfaces of the grass and leaves, forming those glistening droplets of dew. This process is a delicate balance of temperature and humidity, creating a picturesque scene each morning. You've probably experienced condensation firsthand if you've ever worn eyeglasses on a chilly day and walked into a warm room. The sudden change in temperature causes an immediate reaction. Your lenses fog up because the warm, moist air from the room comes into contact with the cold surface of your glasses, causing the water vapor to condense into tiny water droplets. This is a common occurrence and can be quite frustrating for those who wear glasses regularly. The science behind this is simple yet fascinating. When warm air, which holds more moisture, meets a cooler surface, the air's capacity to hold water decreases. This results in the excess moisture turning into liquid form, which we see as fog or condensation. This same principle applies not just to eyeglasses, but to many other everyday situations. For instance, when you walk from a cold outdoor environment into a warm indoor space, your glasses fog up almost instantly. Another common example is car windows fogging up on a cold day. The warm air inside the car meets the cold glass, leading to condensation. This can be a safety hazard if not addressed promptly. Condensation is not just a minor inconvenience. It plays a significant role in nature. Dewdrops on spider webs, for example, can create stunning visual effects when hit by sunlight, turning ordinary scenes into extraordinary displays of natural beauty. Morning dew on flowers and plants also helps in maintaining the ecosystem. It provides a source of water for small insects and helps in the hydration of plants, especially in areas where rainfall is scarce. The formation of dew is a nightly occurrence that often goes unnoticed. However, it is a crucial part of the natural water cycle, contributing to the overall health of the environment. So, the next time you see dewdrops on grass during your morning walk, take a moment to appreciate the intricate process of condensation. It's a small but vital part of the natural world that adds beauty and balance to our surroundings. And when your eyeglasses fog up, remember that it's the same natural process at work. Condensation is a fascinating phenomenon that connects the mundane with the marvelous, reminding us of the intricate workings of our world. Whether it's the dewdrops on a blade of grass or the fog on your eyeglasses, condensation is a testament to the wonders of nature. It's a simple yet profound process that enriches our daily lives in ways we often overlook. Embrace the beauty of these small moments, for they are a reminder of the delicate balance that sustains life on Earth. Section 7. Precipitation. Water falls back to Earth. This is a crucial part of the water cycle, a continuous process that recycles Earth's water supply. Without precipitation, life as we know it would not be possible. It replenishes our lakes, rivers, and groundwater, providing the essential hydration needed for all living organisms. As more and more water vapor condenses in the atmosphere, it forms clouds. This process begins when the sun heats up water in oceans, rivers, and lakes, causing it to evaporate and rise into the atmosphere. As the water vapor ascends, it cools and condenses into tiny droplets or ice crystals, depending on the temperature. Clouds are simply collections of tiny water droplets or ice crystals that are light enough to float in the air. These droplets or crystals cluster together, forming the clouds we see in the sky. The type of cloud formed can vary greatly, from fluffy cumulus clouds to thin, wispy cirrus clouds, each playing a different role in the weather patterns we experience. When these water droplets or ice crystals in clouds grow large and heavy enough, they fall back to Earth as precipitation. This process is influenced by various factors, including air currents and temperature changes. The droplets combine and grow until they are too heavy to remain suspended in the air. Precipitation is any form of water that falls from clouds to the Earth's surface. It is a vital component of the Earth's hydrological cycle, ensuring that water is distributed across the planet. This distribution is essential for maintaining ecosystems, supporting agriculture, and replenishing freshwater resources. This includes rain, snow, sleet, and hail. Each type of precipitation has unique characteristics and forms under different atmospheric conditions. Rain, the most common form, occurs when water droplets coalesce and fall to the ground. Snow forms when temperatures are low enough for water vapor to crystallize directly into ice. The type of precipitation that falls depends on the temperature of the air that the precipitation falls through. For instance, if the air is warm, precipitation will likely fall as rain. If the air is cold, it may fall as snow or sleet. Hail forms in strong thunderstorms where updrafts carry water droplets upward into extremely cold areas of the atmosphere, causing them to freeze and grow before falling to the ground. Section 8. Diverse precipitation, rain, snow, sleet, and hail. These are the four primary types of precipitation that we experience on Earth, each with its own unique formation process and characteristics. Rain is the most common type of precipitation. It is essential for life on our planet, providing the water necessary for plants, animals, and humans to survive. It forms when water droplets in clouds collide and combine, becoming larger and heavier until they fall to the ground as rain. This process is known as coalescence. The size of the raindrops can vary, and they can fall as light drizzles or heavy downpours, depending on the atmospheric conditions. Snow forms when the temperature in the clouds is below freezing. This typically occurs in colder climates or during the winter season in temperate regions. Instead of forming liquid water droplets, the water vapor freezes directly into ice crystals, creating snowflakes. Each snowflake is unique, with intricate patterns that form as the ice crystals grow and combine. The beauty of snowflakes has fascinated scientists and artists alike for centuries. Sleet is a mixture of rain and snow that freezes as it falls through a layer of cold air near the ground. This can create a slippery and hazardous surface, making travel difficult and sometimes dangerous. And hail is a type of precipitation that forms when updrafts and thunderstorms carry raindrops high up into extremely cold areas of the atmosphere, where they freeze into balls of ice. These ice balls can grow larger as they are lifted and dropped multiple times within the storm, eventually falling to the ground when they become too heavy for the updrafts to support. Hailstones can cause significant damage to crops, vehicles, and buildings. Each type of precipitation plays a crucial role in the Earth's water cycle, contributing to the distribution of water across the planet. Rain replenishes rivers, lakes, and reservoirs, providing fresh water for drinking and irrigation. Snow, on the other hand, creates a winter wonderland, offering opportunities for winter sports and activities. It also acts as an insulating layer for the ground, protecting plant roots from extreme cold. Sleet, while often seen as a nuisance, is a reminder of the complex interactions between temperature and moisture in the atmosphere. It can create challenging driving conditions, requiring caution and preparedness. Hail, though destructive, is a testament to the power and intensity of thunderstorms. It serves as a reminder of the dynamic and sometimes violent nature of our weather systems. Understanding these different types of precipitation helps us appreciate the complexity and beauty of our planet's weather. It also underscores the importance of weather forecasting and preparedness in mitigating the impacts of severe weather events. Meteorologists study these precipitation types to better predict weather patterns and provide accurate forecasts. This knowledge helps communities prepare for and respond to various weather conditions, ensuring safety and resilience. Whether it's the gentle patter of rain, the serene fall of snow, the icy mix of sleet, or the dramatic impact of hail, each form of precipitation adds to the rich tapestry of our weather experiences. They shape our environment, influence our activities, and remind us of the ever-changing nature of the world around us. Section 9. Collection water gathers in various places. Once precipitation reaches the Earth's surface, it collects in various places. Some of it soaks into the ground, replenishing groundwater supplies. Some of it flows downhill as runoff, eventually making its way into rivers, lakes, and oceans. And of course, some of it evaporates back into the atmosphere, starting the cycle all over again. The water cycle is a continuous loop, with no beginning and no end. Section 10. The importance of the water cycle. The water cycle is incredibly important for life on Earth. The water cycle provides a constant supply of fresh water, which is essential for all living things, from tiny insects to giant whales. The water cycle helps regulate Earth's temperature, distributing heat around the globe. It also plays a crucial role in shaping Earth's landscape, carving out valleys, forming rivers, and creating canyons. Without the water cycle, our planet would be a very different place. Section 11. Conclusion. Stay curious. Well, that's the water cycle in a nutshell. From evaporation to condensation to precipitation and collection, this amazing process keeps water flowing on our planet. Remember, science is all around us, so keep asking questions and exploring the world with a curious mind. And don't forget to subscribe to our channel for more exciting science adventures. Until next time, stay curious.